all through Mexico by bus. And we were supposed to eat real good foods. It was all organized and always bottled water, but we didn't always. And I kid you not, those soccer players were on the team, on the fields in towns all over Mexico. We did, I don't know, 3 weeks. It was 3 weeks. Every day we played. And I kid you not, these Point Loma College students had the runs so bad. Montezuma's revenge. They were running with their knees together, just trying to keep it. They couldn't hold it in. That's what I'm saying. All right. Let's go on. Greenhouse gas. What is a greenhouse gas? It's a gas that has a high specific heat, guys. Has a high specific heat. What does that mean? It means it holds heat longer than other gases. And the examples I've used were carbon dioxide and methane. And one other, the most important one, water vapor. Water vapor. And I talked about that in today's lecture. Let's go on. Particulates are solids in the air. They become the nuclei of raindrops and snowflakes and hailstones. Why? Because water is attracted by a property of water called capillarity. You don't need to write it down. But this property of water is attracted to solids. Water is attracted to solids. If you do not believe it, I imagine I'd put a drop of water between my thumb and index finger. And then I spread my fingers. Can you visualize how water will stick to my upper finger? Can you visualize that? Why? Because water is attracted to solids. There's a solid on the bottom, but there's a solid on the top. And it will resist gravity. And it won't fall to my thumb. It'll remain sticking to my upper finger. In the same way in the atmosphere, water in the air is attracted to solids. These solids are called particulates. So they're very, very important in the atmosphere. And they're dust particles and pollution particles. Even bad stuff we don't want to inhale. But they're good for raindrops. Thermal layers. I want you to know where the tropopause, I beg your pardon, where the troposphere, the stratosphere, and the thermosphere is. So the tropopause is not important. It is and isn't. Troposphere, stratosphere, thermosphere. Those three, you'll see them named on the exam. What is important? In the troposphere, air cools as you rise. From today's lecture, let me ask you a question. In the troposphere, air cools as you rise. What do we call it when the opposite happens?
Interval.
Not interval. Temperature in inversion. Temperature inversion. So I apply this to the last thing we talked about in today's lecture. Do you see that? Now, you've got to be able to make that application for the exam. And you'll be able to do it easily if you go over it and over it and over it. But you've got to go over it and over it and over it. You have to. And I can't do it for you. I'm doing it now. But over the weekend, guys, 8 or 9 or 10 hours, I'm telling you, you go over it and over it and over it, you'll do so much better. Many of you who would have gotten F's will end up with C's and B's. And probably you'll find that A's are impossible for you. If you find that's true, please don't be upset. Please don't be. I'll never be upset with you. I know that for many people this material is difficult. I know that. Some of you it'll be pretty easy. You find you study 3-4 hours, you get an A. I did. I admit it. And I made it my college major. Concentrate on your strengths. Okay, let's go on. In the stratosphere, what's important about a stratosphere? It gets warmer as you rise. Why? Because of ozone. Let me say that again. In the stratosphere, it gets warmer as you rise. Why? Because of ozone. In the stratosphere, it gets warmer as you rise. Why? Because of ozone. And what does ozone do? It captures ultraviolet and it protects my lily white skin from the ultraviolet. And I am protected. That's right. If I weren't protected, I would have died at a younger age from ultraviolet messing up with my skin cells, bringing about skin cancer, and I'd have been in the ground, and nobody would have cared. My wife would have cared for a week until she found another man. I'm just teasing. I'm teasing. She'd never even want another man, I don't think. Okay, and then in the thermosphere, it gets warm, and look at how warm it gets. It gets warmest of all. The air molecules in the thermosphere are really, 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 really warm. They're cooking hot. Look at this. 3,000 degrees. That's how hot the air molecules can be up there. Why? Because of the really intense rays of the sun, gamma and X-rays. Doing what? Blowing atoms apart and creating ions. So what do we need to know about the thermosphere? That is where atoms convert to ions and protect the Earth from the most intense rays of the sun. The X-rays and the gamma rays. Okay, so let me run through this one more time because it's so important. Thermosphere cools. No. Troposphere cools as you rise. Stratosphere warms as you rise because of ozone. Thermosphere warms as you rise because of ozonation or ozone formation. Does that make sense? And what about ozone? Ultraviolet. What about, did I say ozonation? I lied to you. In the thermosphere, it's ionization. Ion formation. Ion. I-O-N. You all should remember and know what an ion is. A broken atom. Now, in the thermosphere, we have the ions protecting us from gamma and X. Right? In the stratosphere, we have ozone protecting us from ultraviolet. Is that all clear in your notes? That's it. That's enough. And that's a lot. I know it's a lot. As you rise, it gets cooler. I've already said it 20 times. Something else. As you rise, you lose air pressure. The air pressure is greatest at sea level and lower, lower, lower as you get up. Air pressure is at 50% at 20,000 feet. That will be an exam question. I'm not joking. I'm not telling you how I'm going to word it, but that will be a question. So you need to know 4 miles up, but on the exam it'll say 20,000 feet, 6.4 kilometers, but in the exam it'll say 20,000 feet. You need to know. What do you need to know? That half of the air is beneath your feet and half is above you. Half of the air. How does that relate to air pressure? You have 50% of the air pressure. That means the air that's pressing in on your eardrums is only 50%. If you were to quickly leave this room, open the door, and step out there, and outside was only 50% of the air pressure, it'd blow your eardrums right out of your head. Because you have full air pressure inside your head, outside you have 50%, and your eardrums would explode. Literally, your eyeballs would pop in your sockets. Probably wouldn't pop out of your sockets. But I guarantee you it would cause you a lot of pain. But if you go up to 20,000 feet and you do it gradually, your body adjusts. Does that make sense? Because the body is marvelously designed, part of the Goldilocks planet, and we are wondrously adaptable. 20,000 feet up, half of the atmospheric pressure. Here you see a chart. Same thing. Atoms have a nucleus with protons and a shell with electrons. If you remember that, you're going to do well on the exam. How much more? Nothing. If you forget the word shell, you're going to blow it. If you forget the word electron, you say, oh, wait a minute, is the electron in the center or on the outside shell? You're going to blow it. You've got to remember, protons are positive in the nucleus. Electrons are negative in the shell. Chemical bonds, I have no questions on that. It's very complicated. I spent a lot of time on it because it's important. You have a basic understanding, but I'm not going to put it on the exam. Okay? And everybody that left the room doesn't know that. But you do. Shell, electron. See the purple words? Those are words. A lot of interesting stuff. What do you need to know? Fission and fusion. Fission is when a nucleus is divided. Fusion is when two nuclei or more bond together. The result is a big bang. Great big bang. El Grande Bango. I've been watching Telemundo. Fusion is when the nuclei come together. Does that make sense? What word do you need to remember?
Chlorofluorocarbons.
There it is. It'll be on the exam, I'm telling you. What do you need to know about chlorofluorocarbons? They are believed, no, there's no belief, it's true. They break up ozone. That is true. Do you need to know my opinion about how they function in the stratosphere? No. I freely share my opinions. I do not expect to test you on my opinions. But I will always share my opinions because I think they're important. And I want to test you on it. What I'm going to test you on is the science. Yeah, check it out. We're doing good. I've only been doing this for about 30 minutes, a little over 30 minutes. We're through 3 out of 4 lectures. That means in 30 minutes, 45 minutes time, you can do all the study you need to. But you need to do it again, and again, and again, and again, until you're so sick of those purple words. Every time you see purple, you vomit.
You mentioned plasma as being the fourth seed of matter. Do you need to know anything in particular about plasma?
It is broken up atomic particles. That's about it. It is what makes up solar wind. Okay? So, in fact, let's go through some slides now and talk about plasma. Just a little bit, but you don't need much. Insulation, I never told you this, and I don't think there's an exam. I hope there's no exam question. But I'm telling you, insulation means incoming solar radiation. You see it? Insolation. Incoming solar radiation. This lecture is about incoming solar radiation and temperature. Characteristics of temperature. And again, mostly hydrogen. Solar flares. What do solar flares produce? Solar flares produce solar wind. Solar wind reaches the earth, it luminesces, causing aurora. In the north, aurora borealis. In the south, aurora australis. Energy, heat. This one is very important. Heat. What is it? Vibration of atoms. Heat. What is it? Vibration of atoms. What is heat?
Vibration.
Vibration atoms. You got it. You're there.